Hi, and welcome to this fourth lesson in the arithmetic of surds. This time we're going to look at simplifying surds. Well, can surds with large values be simplified? Now remember, we've just learned that the square root of a times the square root of b was equal to the square root of the product of a and b. So something like the square root of 24, what we could say is that came from the square root of 1 times the square root of 24, the square root of 2 times 12, the square root of 3 times 8, or the square root of 4 times 6. Now what we can see is that there's no way of simplifying 1 times 24 using surds because 1 and 24 are not squared numbers. Similarly for 2 and 12. 3 and 8, we also have the same problem. Neither 3 nor 8 are a squared number. However, the very last one contains a squared number. And we know the square root of a squared number can cancel and simplify to an integer. So what we have to do is we have to use what we learned before about the square root of a times the square root of b equaling the square root of ab, and we need to undo 24 and turn it into the square root of 4 times the square root of 6. We know that the square root of 4 can turn into 2, and that leaves us with a multiplication of an integer times a surd, which we learned in a previous lesson, just gave us 2 root 6 in this case. So the kind of question you could come across would be to simplify the square root of 32 into a surd in its simplest form. So we take our 32 and we think of the factors. So we've got 32 times 1, we've got 16 times 2, we've got 4 times 8. The first one doesn't have any square roots, so therefore we can ignore that one. However, both the second one and the third one do contain a square root. 16 is a square root that can be worked out, and 4 is a square root that can be worked out. So if we do the same process as before, we split up our two values into the two surds, then we find that that gives us overall 4 root 2. If we do the same with the next one, we end up with root 4 times root 8, which gives us 2 times root 8, which then gives us 2 root 8. So we have two possible answers here, but one of them has to be right and the other one can't be. Now if we take a look, the question did say in its simplest surd form. So in this case we're looking for the surd that has the lowest number underneath the square root sign. So in this case, if we disregard all the working and we take a look at the two possibilities that the answer could be, then it should be clear to see that the only one that has the lower is the root 2 version. So we can ignore the 2 root 8 and we've now got a situation where we can say that the square root of 32 is the same as 4 times just root 2. Okay, so here we have another problem, and a quicker way to look at it is to only consider the surds which can simplify. So in the square root of 48, we have 1 times 48, which contains the squared number 1. We have 4 times 12, which contains the squared number 4. And we have 16 times 3, which has the square number 16. So if we go through the process once again, and we can see that the first one, it doesn't really make a great deal of difference, it just gives us 1 times root 48. The second one does simplify, and it gives us 2 root 12. And the third one, it simplifies, and it gives us 4 root 3. So if we bear in mind what happened in the last question, we can see we can ignore the root 48 and the root 12 versions, and only consider the root 4 root 3 version. So we now know that the square root of 48 can be written as 4 root 3 in its simplest form. Right, so now once again we've got something for you to try for yourselves. So in a second when they appear, pause the movie, try them for yourselves, and then we'll check your answers afterwards. Right, let's look at some of these answers here. So the square root of 12 becomes 2 root 3. You know that 4 times 3 makes 12, and the square root of 4 is 2, giving the answer 2 root 3. Root 20, that's 4 times 5, and we know that the square root of 4 is 2, so that should give us 2 root 5. 27, now if you think of the squared numbers, 1 won't go into that, 4 won't go into that, but 9 will. So we could see that that's root 9 times root 3, and the square root of 9 is 3, so we end up with 3 root 3's. 128 is a bit more challenging, but what you may remember is that 64 is a squared number and two 64s make 128, so this time if we do the square root of 64 it's going to give us 8 lots of root 2. Next one, root 40, well that one there, 1 won't go, will go in, but 4 will go in and nothing else, so what we can say here is that the simplest version is going to give us 2 root 10. The next one, 240. And that one there gives us 4 root 15. It might take a wee bit more work to work that one out, but if you split it into its factors, 1 times 240, 2 times 120 and so on, you'll eventually get to 16 times 15 gives you 240. 16 is the one that's got the largest square number in it, so you can simplify that to 4 root 15. 96, that one there's 16 times 6, just in case you didn't get it. Square root of 16 is 4 times root 6. And the last one, that's a bit easier. 100 is a square number, so that can split up into the square root of 100 times the square root of 2, which then simplifies to give us 10 root 2. So hopefully you've learned how to look for the factors in a surd and simplify it down to find the one that gives you the simplified version in the lowest surd form. Okay, your teacher will probably direct you towards some more examples to practice this, but thanks for listening.